In Lesson 4, students were estimating products by rounding the greatest factor. We started to take a step in the direction of being able to work to this goal of multiplying a whole number up to 4 digits by 1 digit. Yesterday we were looking at problems where we had 2 factors, and we haven't quite figured out strategies just yet for solving to find the exact answer of this problem, but students were using their mental math and their patterns with basic facts to be able to round numbers in order to estimate what the product would be. So looking at the basic fact, 4 times 5 is 20, and then adding 2 zeros onto the product, so that students can start to see the reasonableness of their answers when they multiply to find exact answers with up to 4-digit numbers. In today's lesson, we started investigating how we could break apart factors in order to simplify or make a problem simpler so that we could find the product of a larger number. This will help us as we move into more strategies this week and slowly kind of take a step in a direction where they can solve problems much quicker based on these strategies we're working towards. So in today's lesson, they started by using grid paper to outline 6 rows of 13. And for this problem, I asked students to break apart the 13 within the model so that there were 2 smaller rectangles. So thinking of 13 and how we can break it apart into 2 smaller pieces, it could be 8 and 5, 10 and 3, 6 and 7. There are several different ways students could break apart this grid. So for the first one, let's assume that they broke it up into 8 and 5. And so students could look at these 2 smaller problems. Instead of 6 times 13, they could find the product of 6 rows of 8 and 6 rows of 5. By doing these smaller products, students can use their basic facts and then go back and combine them to find the actual product of our larger number we started with. So 6 times 8 and then 6 times 5. And students could combine those 2 products to figure out what the actual product of 6 times 13 is. And that, in essence, is the distributive property. The distributive property says that you can multiply a sum by a number, and that's the same thing as multiplying each addend by the number and adding the products. So to simplify and kind of make that a little bit clearer, by doing 6 times 2 different numbers that add to get 13, we're breaking apart the 13. So another example of breaking it apart is 10 and 3. 10 plus 3 is 13. So we're really looking at the same factor, but we've broken that apart into 2 smaller addends. So by multiplying 6 times 10 plus 3, it's really like multiplying 6 times 10 and 6 times 3, which in a grid we could see by representing 6 rows and then 10, and that would be this amount, and then 6 rows with 3 in each. So we're just taking the rectangle and breaking it into 2 smaller pieces. Then by finding these smaller products, we can go back and add those smaller products together. And these 2 numbers are called partial products. So 6 times 10 is 60, and 6 times 3 is 18. Those are the products that you get by adding two smaller pieces. So these two are called partial products. By adding those two numbers together, we find that the exact answer of 6 times 13 is 78. Modeling it again, we could think of another way to break apart 13. This just shows that we can do 6 times 6 and 6 times 7, thinking about 6 times 13 as just 6 plus 7. So when we get that, we can get 36 and 42. When we add 36 and 42, which are two simpler problems, we can add them together and get that same product of 78. So breaking apart the model in yet a different way, we'd still start off with 6 and 13, but we're breaking this number into 6 and 7. Finally, we looked at how this rectangle or the area model with grid paper could be used with base 10 blocks and how it's similar. Students know that base 10 blocks represent ones, tens, hundreds, thousands, and so on. So when we think of the problem 6 times 13, it's really 6 rows of 13 or 6 groups of 13. And so to break apart into tens and ones, because our base 10 blocks represent those, it's really like saying 6 rows of 1, 10, and 3 ones. And you'll see that in the image here. So for step 1, we have 13 in each row, 1 10 and 3 ones. We've broken it up, and now we can represent 6 times 110 or 10 here, 6 rows with 110. And then in our ones, we have 6 rows with 3 ones. We can easily mentally solve these partial products. 6 times 10 is 60. 6 times 3 is 18. When we combine them together and we're adding them, we're adding the partial products. So we know 60 plus 18 gives us 78. So 6 times 13 is 78. In student spirals, we did an example together where they were using a rectangular model, just like we saw in the previous problems, to break apart a factor. With this model, we have 9 rows and 14 in each of those rows. To break them up into 2 smaller rectangles, we try and get students to break apart the tens and the ones. 14 has 4 ones and 1 10. This helps with mental math because we know that when breaking these 2 smaller rectangles up, we know 9 times 10, and we know 9 times 4. And that can help us solve a problem that we might not know in our head, like 9 times 14. So these are the two multiplication sentences that make up 9 times 14. And this is how we would write it with the distributive property. Now solving with the partial products, 9 times 10 is 90, and 9 times 4 is 36. Those are partial products because they're just 2 smaller products that we've created from this problem. We can add them together to find the sum, and we know that it's 26. Students worked on these two problems by themselves to try and break apart the model as we've done as a whole group. And so for this one, I'm not going to use the grid, but they start with 3 rows and 13, but we're going to break that 13 into tens and ones. It's 3 ones and 1 10. To use the distributive property, instead of doing 3 times 13, we're now doing 3 times 10 plus 3. Those are the two numbers that we broke apart, which is the same thing as saying this first partial rectangle here is 3 times 10, and we're going to add it to the second partial rectangle, which is 3 times 3. 3 times 10 is 30, and 3 times 3 is 9. So our final product of 3 times 13 is 39. Students could probably find out something like 3 times 13 pretty quickly with other strategies, but we want them to get familiar with what the distributive property looks like and how to break apart factors in ones, tens, hundreds as they move into greater numbers so that they can be more familiar and comfortable with these strategies. Lastly, we looked at how we would see this in a word problem. We have an image here. Kyle went to a fruit market. The market sells a wide variety of fruits and vegetables. The picture shows a display. So this display can hold 8 rows of 12 oranges, but 2 rows are empty. So how many oranges are in this display? This really looks a lot like our area model with a rectangle. And it looks like we need to find out how many rows there are. There are 6 rows. 2 of them are empty, which is why we don't actually have 8 rows, but we do still have 12 rows here. If your students know basic facts, they could do 6 times 12 and find out how many oranges are in the display. We know that it is going to be 6 times 12, and that's the equation that we want to solve for, is how many oranges there are. To use the strategy that we learned today, we could draw using grid paper, or just like I've been doing, sketching a rectangle with 6 and 12, but we want to break up into smaller numbers. 1 10 and 2 ones is the same as 12. 6 times 10 is 60, and 6 times 2 is 12. So by adding these two smaller numbers, we know that there are 72 oranges that are in the display.